Start recording. Okay, so we're recording now. So nothing greatly has changed here, as you can see. Let's start with talking a little bit about splines. I want to go back over this to make sure that we're clear on it and we know what's going on. So I'm going to just create a quick spline. And we're going to draw a spline. And if we recall, until we edit the spline, it's a straight line from one point to the other. We can adjust with the triangle the angle of it. The diamond is adjusting the curvature. If you grab the circle at the very end, you can adjust everything. Now, keep in mind too, again, I like a simplistic spline. The least amount of points I can use to get the job done or to get that shape I want is what I want to utilize. So I can go with one, and you can see I've got a fair bit of control over what I'm going to make this spline look like. If I come in and I create another spline with multiple edit points, I have a little bit more control over where I can move things. I can get that S curve. You can see I can mess it up quite a bit there. But I also want to take a look at this and say, okay, what are my curvature combs? And what I'm going to do here is I will draw another one using those same points. So you can see here, I can adjust it. Now, how many, I don't remember if I went over this last semester, but what do these curvature combs represent? Does anybody remember?
How much light reflects off of it?
Yes, that's the end result. So what the curvature combs do is they represent the rate of acceleration on a curve. And what a rate of acceleration means is if I come in and I draw a line and I toss on a curvature comb, there is no comb because there is no rate of acceleration. The acceleration of that curve does not change. It's a constant. Now, if I come in and I adjust it a little bit, you can see that there's an arc to the curve. So how quick or how much does that curve arc in that particular area? Because if we break this down and we look at it, and let's come in and we'll go evaluate. And we'll dimension it. It's not. You can see here, it's not going to let me do that. So this could be considered a constant rate of acceleration. There is no increased acceleration. So what it's saying here is this is a large radius. Oops. It gets to a tighter radius. So that curve accelerates. What that also means is, because that surface is going to accelerate, the highlight is going to accelerate. So here it's going to be very flat, very washed out, and then as you get into this point here, it's going to wrap around quicker. Think about a ball. the ball up here, falling this way, is going to go quicker. If it goes down the backside, it's going to go slower. So that's what the highlight is doing. Now, we can get a variety of things going on just by using the 2 points, and we can get very nice things. Now, we can do the same here, but you can see now, by having that point there locked, we're going to get a bit of a dip. It's not a smooth transition. It's going to be like a flat spot. So you no longer have, I know it's hard to see on the white background, we no longer have a very smooth, gradual transition. So if this is the curve we need, then that's what we need. But is that going to be a nice form? Is that going to be pleasing to the eye? Or is the highlights going to wobble? So let's just come over and we're going to move this over here. We're going to move this here and we're going to move this here. And what I'm going to do is just really simply, I'm going to use the most basic surface command that there is, which is an extrude. An extrude is a single profile going in one direction, creating not necessarily a flat surface, but a straight line. So if we come in now and we look at our curves and we've got those rates of acceleration, and you know what, let me go back and do one more here. There we go. So we've got multiple curves. One that has a very gradual, consistent transition. One that is a little bit more aggressive. One that has multiple points, a little bit more complex, but not necessarily the nicest looking. And one that has a gradual transition into an extremely sharp, tight round. So if we come in here and we're just going to go in, and I bounce back and forth. I don't have the, there. Bear with me here. There we go. Okay, so we're just going to go into here and grab a paint. So if we look at our surfaces, you can see on that first one that had a very smooth, gradual transition, we've got a flat, wide highlight. Because that's what happens. If you think about the sun hitting a flat surface, that's what you're going to get. Now, wherein we had one that's got a little bit more of an acceleration there, it's going to tighten up. Same as up here, it was a gradual acceleration, so it has that flat option. Now, you can also see, let me come in here and do this though. That's fine. If we look at this, see here where we had that wonky surface, where the curvature combs represented like there was a little bit of a wave and a dip in there. you can see you've got a highlight, and then a flat, and then a highlight. So those curvature combs are representing what that surface is doing in those areas. What those surfaces are doing, going to a arc, to a flat, back to an arc, is going to be representative of how the highlights, how the light reflects back off of it. Same as if we look at this one here, you can see where that surface was flat, we've got the nice big washed out highlight. And then as it comes around here, it becomes a tighter, more refined highlight, right down to a tight radius, more of a pinstripe. That's helping you to see that, where if we go back to SolidWorks now, you can see that's exactly what we're getting. That greatly increased acceleration is what's getting that tighter highlight. Yeah, Fabian. Your volume's not on, Fabian. Or Mike.
Me and Goofer have the same question. How did you get the this net that's like showing you where the curve is going to be? The yellow net.
Oh, I'm sorry. Okay, yep. So that tool, there's a couple different tools for that. So if you click on the line, right click, and what you have is show curvature combs. So I can turn that on and off. I can also click on it here. Over on the spline box, I can say show curvature. What I can also do is control the scale and the density. So the scale is how high up do they stick out. So I'm just going to bring them down a little bit, so they're not blowing up off the screen. I can also control the density. And the density means how many lines is it representing. You know, so how much do you need, how much do you not need? Was that the question? Okay. So the sharper the curve, the sharper the radius, the tighter the highlight. We all understand that, right? Okay. So this is why you can see being very, very careful to get what we want and to get it right. Let me... I'm not going to be able to do this here that quickly. I've discovered that I've lost my... Well, you know what? I'm going to do this. Okay. Of course, they're all mathematical equations. You know what? That's going to work. No, it's not. Bear with me. Oh, of course. Sorry, I thought about this after the fact. Okay. Tools. Where's my insert? Sketch tools. Sketch picture. Okay, so what we've got here is French curve, obviously. Now, one of the things that, as an exercise, I'm going to have everyone do is you're going to take a variety of sketched lines or curves, and from what you would consider simple to complex, and there's going to be 9 of them, and I'm going to want you to generate a spline that is the cleanest, simplest spline you can do that matches that. So here, I'm going to come in and create a new sketch. And again, it's about taking the time up front to get your surfaces right. So I can come in here and adjust it. And play with it to get it to where I want it to be. And a lot of people will automatically go, oh, well, you know what? There's not enough. I only did 2 points. So I'm going to come in and I want to add another point. You know, or they're going to do, okay, so let me show you 2 things. So here I say the most simplistic one that you can. 2 points. So someone comes in, they create the 2 points, they come back, and they say, this is my sketch, this is what I want it to look like. Well, I can't seem to quite get it. So instead, I'm going to go and do 3 points. So I'm going to come in and I'm going to go 1, 2, 3. And I'll try to get this adjusted right. And you can see there it's starting to look a little bit better. And I'm matching my curve. Now, keeping in mind, when we do a sketch, it's not perfect. Our lines aren't perfect. So we don't want to just simply trace the sketch 100%. But if we look and we say, okay, how does that look? So this is, again, this goes back to the build, evaluate, and refine. So we want to evaluate it, and we're going to come on our curvature combs. And we can see here, what this shows is that the surface dips under. So that puddles there. Do you guys understand what I mean by that? Or can you see that? Okay. Which, if that's not what we want, then we need it to be all the way up like that. Well, now, in order to do that, we're way off of our curve. So then we need to continue to refine a little bit more and try to get it optimized. Now you can see, as we're doing this, our curve is not nearly as nice, not nearly as clean as we want it to be. This all shows up in your highlights. This all shows up in your renderings. This all will show up in, if you do a 3D print, it will show up when you paint the material. Or if you're using a glossy material, all these things will show up. So we want to make sure that we have an understanding of what a good form looks like. So even though it looked like we could get a little bit better, it was still somewhat complicated. Now this wasn't getting what we wanted. Oops, I turned that on to construction. There we go. It wasn't getting what we wanted, but it's still a little bit cleaner. So we could play with this a little bit more. And figure out what we're doing here to get it to be what we want. Less points, less things to move around and to adjust. Now, here we could say it doesn't match our sketch perfectly, but are we happy with the way that looks? I want to make sure it accelerates around here and it's nice and flat back here. Am I happy with that? That's going to be the question. Now, there are times, and I want to remind you guys of this, there are times where I like to use the splines. And what the splines that I've been using are referred to as a spline. The one I also like to use is what's referred to as a style spline. And what a style spline is it allows me to utilize points to create the curve. So I'm going to try to recreate that, but I'm going to put 1 point here, and I'm not going to put, if I just do 1 point there, I can't create a curve, because I need more than 2 points. I need to have a point, and then that point is going to define in between. And now instead of using those control handles, I use what's known as the control points to move things around. I personally find that I can move these things around a little bit quicker, a little bit easier than I can the other ones. They've got pros and cons. The spline, I can get down and I can actually dimension it. And make numeric values to it to get it to be more precise, more controlled. I can do that with this spline, but it takes a little bit more effort. So if I come in, I'm going to come in and I'm going to say, okay, show my curvature combs. That looks pretty good for what I want. In comparison to that, there was a lot less adjustment to get where I want it because I could see it better. Now, if I need to say, hey, I'm trying to get it to match this and wrap all the way around, but I don't think I'm ever going to get there, because you can see that as I move this point around, it's adjusting to only a certain extent on the curve. As I move this one around, so you can kind of see it's broken out into two big halves. This one moves this section about 80%, and it adjusts the back section about 80%, 20%, and vice versa. So I say, you know what? I need another point. I can right click. I can go to Insert Control Vertex. It says, where do I want to insert it? Well, I feel I have enough control between here and here. I've got enough control between here and here. I can't get this area to be refined. So between here and here, I need to add a control point. I click on that line. Now, I've got one extra control point. So I can come in and start adjusting things. And looking at what I want. And I'm saying, you know, hey, I understand my sketch. I want to make sure my curve matches that. My design was to have a nice big bull nose, let's say, you know. So I want to make sure that that's consistent all the way around without actually using a circle to model it. Now, for me, I find adding in a control vertex point using the style spline is quicker, easier, and simpler than having a third point in here to move around. I end up with a much cleaner sketch. So, one of the things too I want to talk a little bit about as we're doing surfaces in that, and as we do splines, I'll see if I can duplicate this. Your spline controls your surface. Oops, that's not what I want. And it comes back to geometry and physics and what you want. So here I have a spline, and I'm going to put I'm going to model it up, and I'm going to say I want a really tight radius on that surface edge. That's what I want it to look like. Now, I'm going to just extrude these very simply or very quickly. And I'm going to say, oh, yep, that's the radius I want on there. Nice, tight, simple radius. Well, here's the problem now. I'm going to come in and I want to thicken this. I want to make it a solid, let's say. So everybody's used the thicken command previously in that. So we'll come into surfaces. We're going to go thicken. $10 millimeters. I was able to get it to thicken, but let's say I want it more than 10 millimeters. Failed to offset or face could not be deleted. Now, this is going to be hard to see. Do you see how this is having this weird folding over? If I drop it down to 10, it's still doing that folding over. The reason it did it at 10 is because Solidworks is looking at it saying, oh, hey, I think you don't want that, so we're going to delete it for you. It's become much more intelligent. But at 15, it's saying, I don't know what you want. So it's not going to do that. So that is one of the issues, because there you can see it folded it over. That's one of the issues of putting really, really tight radiuses into a surface that you're then going to try to shell later or at another point. Same as if we come back and we go to our sketch. I'm going to take this and I'm going to offset it. Now, going outward, you can see it's willing to do 1 mil. It's willing to do 5. Nope. Didn't want to do 5 mil because it's just not there. So that's the same as when you do your surface offsets. It's not going to allow you to do it. The workaround for that we'll talk about down the road is that you would either save this to add as a radius later, or you would do it as a separate surface. But that's one of the biggest things wherein we create splines that are trying to do too much and they can't be offset because they would intersect. We saw that when we did extruding of a circle or a circle, where when you're kind of extruding along a path and it would bend on itself. These are the things that come up with that problem. Now, questions about that? Okay. Let's talk a little bit more about utilizing the different points of a curve. So for this example, again, I like to try to keep things a little bit more simplistic. So if I found that I wanted to create this, but I don't want to get a overtly complex spline, because there's a lot for me to work with here. What we do, or what can be a much easier workflow, because it may be that we want to have a little bit more refinement, because you can see here, as I adjust everything, the entire curve moves. So if I'm adjusting this, it's the age-old thing. One change doesn't affect one thing. One change affects multiple things. So I'm going to come in and I'm going to try to get all of this to be the way I want, but it's almost a uncomfortable, unmanageable spline. So when that happens, and we still want to keep it simple, because you want to control things, look at what is primary, what is secondary. So I'm going to say the most important thing about this arc is going to be this surface here. I want this curve to be beautiful. If I control this, I want this to naturally follow it. So if I come in, I'm going to create my splines. And I'm going to say that's what I like, that's what I'm happy with. Again, I'm going to build, I'm going to evaluate. I know that it flows over, that's fine. What I'm going to then do is I'm going to come back and say, okay, excellent. I want to lock this. I don't want that to move. Then I'm going to build. Oh. I'm going to build my next spline off of here. Now, I want to make sure that this is smooth. You can see right now it comes to a dip. So just like we were doing in the last class, we've got our commands. I'm going to select the line, I'm going to select the other one, and I'm going to say I want to make it tangent. When you watch, you'll notice this first square will move. Oops. So, by making that tangent, this control point, I can only move in the line of that tangency. If I come back, because I made it so that this line is tangent off of that, if I come back, let me get rid of my, I'm just getting rid of the fixed. If I move this, come on, this will always stay tangent. Even up in here, you can kind of see how I'm moving this curve. It is leaving this alone. So I'm controlling my splines and not making it overly complex. We're going to go into a few more things in the next class about how we control the splines and how we get tangency versus curvature continuous. And we're going to talk about the difference between, because I do not believe we talked about curvature continuous much from a surfacing standpoint. That all affects highlights as well. Rate of change, curvature continuous, how does it flow in between your surfaces? Is this, am I diving too deep too quick? Or I'm diving too deep too quick, Fabian? No? Damn headbangers. So I want to make sure that this is building off of some of the stuff that I taught last semester. Okay. Now, you'll notice here, we've got it locked at this. This is tangent. Like I said, I no longer can make that line not tangent. It's always there. It helps me to prevent me from screwing up. But I still have full control. You know, it doesn't look nice because it drops weird. Let's come in and we're just going to go show curvature. Let me there. As you can see, I say that as you can see, you know, it transitions down into here nice, but by moving that all around, I got the big lump. So again, if I'll lay a curve down, add on the curvature combs, and then I'll use that, and I don't actually look at the sketch anymore. I look at what the curvature combs look like. Because my sketch was suggestive. My sketch that I came up with, my concept, is what I would like the form to look like. But it's still, you know, suggestive. The curve that I'm building is going to deviate from my perfect drawn line sketch because I don't think anybody here can draw a 100% perfect curve. You know, there might be a little bit of a wobble in there. So I'm then going to play with and adjust that. Now, let's see. I'm going to hide these. We'll hide that. We'll come back and we'll do, again, simple loft it. You can see here, we've got that dotted line. That's the transition. Okay? We're going to talk about the different types of continuity. Let me just see if I can pull that up here. Are you guys able to see that image well enough? Can you guys see that image? Okay. So this is big for surfacing. How many of you have done your model or your surface model and there seems to be an edge to it where you don't want an edge? Or you run your hand over it and you can feel like a little lump. It's the same as not sanding out your prototype smooth enough. G0 is what's known as positional. 2 points meet. That's all that is required to achieve G0. Doesn't matter if it's a V, if it's a P, whatever. The 2 points touch. G1 means that they're aligned through tangency. There is no angle or deviation between them where they meet. The angle is 0. G2 matches curvature or curvature. G3 is what's known as curvature continuous. And we're going to get into that because, again, each one of these things affects your highlights and how that surface is looking and how that form is going. So right now, if I come back to our sketch, we've got G2, which is tangent. If I come in here, I got rid of our tangency, and even though that curve looked nice, you can see now that we see that break. See how it's a black line? If we come into Photoshop, or not Photoshop, I'm sorry. Oh, why'd that not update? Do we see that edge right there? So that's positional. There's always going to be that edge. No matter what, you're going to see it. That's driven by the curves. If I was, and this is why, from a quick standpoint, I always make sure, and you guys should all have this turned on because I believe you used to, but we want to go under the view, display, wait a second. No. Yes. So under display, tangent edges as phantom. Phantom being those dashed lines. From a drafting standpoint, a dashed line meant phantom. That's where that term comes from. So we always want to make sure that's turned on Because what that does is it allows us to quickly go, oh, I thought it was tangent. Obviously it's not. Because now if I come back, and I can sit there and try to make it better.